Hello and welcome to the Unit 3 Section 5 video on writing functions. When writing a function, you must first determine the independent and dependent variables. Okay, so remember that was the variables that are going to go on your x-axis and your y-axis. So your independent variables on your x-axis and your dependent variables on your y-axis. So the independent variable, again, represents your x-axis. Or you can think of it in terms of your input. The dependent variable represents your y-axis, or you can think of it as your output. Okay, so we have something that goes in and we have something that comes out, and what comes out of the function is your output. So the dependent variable is a function of the independent variable. So this is where the notation that we've talked about in the last section comes from. Y is a function of f, so in other words, we can say that y is a function of x. Okay, I believe I said f, I meant x. Okay, y is a function of x. Okay, so let's talk about how we do this in problems. So a lawyer's fee is $200 per hour for her services. So let's identify the independent and dependent variable. This is something we did earlier in the unit. So the independent variable is our input. So our input is time, or the number of hours spent with the lawyer. The dependent variable is the total price we end up paying. And so we write a function by taking our output, which is f of x. Our output is what our total price is going to be. And how do we determine that total price? Well, we take the price per hour and we multiply it by the number of hours we're going to spend with the lawyer. So 200x, $200 per hour. So if we spend 1 hour with the lawyer, it's going to be $200. If we spend 2 hours with the lawyer, it's 2 times 200, which would be $400, and so on. All right, for number 2, Stephen buys lettuce that costs $1.69 a pound. Here, our independent variable is going to be the weight of the lettuce, so pounds, okay? Because however many pounds of lettuce we buy, that is going to impact our output, or our dependent variable, which is the total price. And again, to write a function for this, we have f of x equals 1.69x, because however many pounds we buy, we have to multiply it by the price per pound, which is $1.69. For example 3, an amusement park charges $6 parking fee plus $29.99 per person. So our independent variable is going to be the number of people that go to the amusement park. Our dependent variable is going to be the total price we pay. Now, unlike the first two examples, this one we're going to have to add something in here. So the total price is going to be determined by how many people we have. So we have to multiply the price per person by the number of people we have. So that's $29.99x. But we also have to add the $6 parking fee to that. So our total price will be $29.99 times the number of people plus the $6 parking fee. So let's talk about reasonable domain and range. We want to determine what values make sense for the problem. So what we're going to do is we're going to plug the input into the function and find the output. Okay? And probably in better terms, we're going to plug the possible input into the function to find the possible output. Okay? I think that makes it a little bit more specific. And you're going to see how that works here in these 6 examples. So for example 1, Manuel has already sold $20 worth of tickets to the school play. He has 4 tickets left to sell at $2.50 per ticket. So our independent variable is going to be the number of tickets that he sells, okay? And he has up to 4 that he can sell. Okay, we'll talk about that in a second. The dependent variable is the total amount sold. Okay, the total monetary amount that he sold. So our function is going to be f of x equals, he has 4 tickets left to sell at $2.50 per ticket, so $2.50 times x for however many more he sells, plus the $20 worth he already sold. He's already guaranteed to have sold $20 worth. What we're trying to find out is he going to sell more than $20 worth? Is it just going to be $20 worth? Is he going to sell all 4 of the tickets? So this is where we talk about what is our reasonable domain and range. So our reasonable domain is going to be 1, 2, 3, or 4. And actually, let's throw 0 in there because he could sell 0 more tickets and just not sell the 4 tickets he has left. That is a possibility as well. Now to find the range, or our output, we're going to plug each of these x values into that function and find out what our outcome is. So if he sells 0 more tickets, $2.50 times x gives us 0. 0 plus 20 gives us 20. So he could sell $20 worth of tickets in the end if he doesn't sell any more. If he sells 1 more ticket, then that's $2.50 added on that, so $22.50. If he sells 2 more tickets, $2.50 times 2 is $5, plus 20 gives us $25. He also could sell $27.50 worth of tickets, and if he sells all 4, $30 worth of tickets. Okay, so I just take each one of these domain values. He could sell 0, 1, 2, 3, or 4 tickets, and you're going to plug that in for x and find out what f of x is. F of 1 is $22.50, f of 2 is $25, f of 4 is $30. Okay? All right, let's try number 2. A construction company uses beams that are 2, 3, or 4 meters long. The measure of each beam must be converted into centimeters. So, our independent variable is going to be the length in meters. Our dependent variable is going to be the length in centimeters. So you need to know what the conversion is. Take a second. Do you know how many centimeters there are in a meter? So we have 100 centimeters in a meter. So our function is going to be our length in meters times 100 to give us our length in centimeters. So we have beams that are 2, 3, or 4 meters long. So that's our input. And our output is going to be the length in centimeters, which would be 2 times 100, which is 200, 3 times 100, which is 300, and 4 times 100, which is 400. So there is our domain and our range for this function, given the possible beam lengths. For number 3, Miss Bareski goes to Dunkin' Donuts every day during the week. She does not go on the weekends. She spends $3.25 per day on coffee. So, what is our independent variable? Well, it is days getting coffee. Because it's absolutely possible that she may miss getting coffee one day or 2 days. Or maybe she's having a hectic week and doesn't get coffee at all during the week. Maybe she just doesn't have time. Okay, we're going to be talking about that domain here in a second. The dependent variable is total spent for the week. And let's go ahead and add that. Total spent during the week. Okay? So let's write our function. F of x is going to equal 325 times the number of days she gets coffee. So our domain is going to be anywhere from 0, because she could just not get coffee at all during the week, all the way up to 5. We cut it off at 5 because we know she does not get coffee on the weekends. So days 6 and 7 are out. So our possible amounts that we spend on coffee, if we plug in each of these x values into that function, will be 0, 325, 650, 975, $13, and $16.25. So at most, she will spend $16.25. At the very least, she'll spend nothing if she doesn't get coffee at all during the week. Now, I want to take a quick moment to talk about how our domain and range have been discrete functions. Okay, we've had individual values in a set. The reason for that is because she cannot get a half of a cup of coffee and pay half of $3.25 for that cup of coffee or that half of cup of coffee. She can only get full cups of coffee. So these are our specific values, our specific outcomes that can occur over the course of a week. She can't spend anything in between these values because she cannot buy a fraction of a cup of coffee. Okay? And that has been the case for the other two as well. In the first example, you can't sell half of a ticket. In the second example, you could, I guess, cut a beam in half, but they're not telling us that that's a possibility. So we're just talking about the original lengths of those beams. All right, for number 4, a kickboxing class is being offered twice a week for 4 weeks. The registration fee is $25 and the cost to attend each class is $10. Again, we are going to be talking about a discrete function because we cannot go to half a class and pay half the price. I very much doubt that they will allow that. So we are going to have a series of values once again. The independent variable, our input, is the number of classes we attend. So number of classes attended. Our dependent variable is going to be the total price paid or the total spent. So now let's lay out our function. Well, we know that we are going to have to pay $10 per class. So that's 10 times x being the number of classes attended, plus we have to pay the original $25 registration fee. So that just gets added on top of the whole price. Our domain is going to be the number of classes we attend. Now, we're not going to start with 0 here because if we start with 0, I suppose we could pay the $25 registration fee and then just not attend a class. But then why would you pay the $25 registration fee? So here, let's assume that you pay the $25 registration fee when you go to that first class and you go ahead and attend that first class. So we have anywhere from 1 to 8 classes that we can attend because it's being offered twice a week for 4 weeks. 2 times 4 is 8. So we could attend 1, 2, 3, 4, 5, 6, 7, or 8 classes. And just like we did with the other problems, we'll plug in those values into the function and we'll get the possible amounts that we pay. 35, 45, 55, 65, 75, 85, 95, or if you attend all classes, you'll be paying $105. And if you think about it, this makes sense. You pay the $25 up front plus $10 for that first class, that's $35. Each additional class is $10 more. So it makes sense that each additional class you go to will be another $10 spent. So that's why we're in increments of 10. All right, let's check out number 5. Sarah has a summer job that pays $12 per hour, and she works between 20 and 35 hours per week. We are going to write a function that represents the weekly salary and then find a reasonable domain and range. So, just like the other problems, let's identify our independent variable. So, the independent variable, our input, is the number of hours worked. Our dependent variable is going to be the total amount earned. Okay? So let's write our function for this. So the amount that she earns depends on the number of hours she works. So For each hour, she gets paid $12 times the number of hours worked gives us the total earned. So if she works 1 hour, she would get $12. If she works 2 hours, she would get $24. But our domain is specified for us. She works between 20 and 35 hours. Now, this is going to be different than the other problems that we've done so far because you can get paid for working half an hour, a quarter of an hour, for 10 minutes. It does not have to depend on working 20, 21, 22, 23, 24 hours, and so on. You can get paid for the fraction of the hour. So, our domain, we are going to include 20, and we are going to top out at 35. So it's going to be anywhere between 20 and 35 hours. So our pay will be some range that goes between that as well, depending on those two values. So on the bottom end, if we put 20 in, 12 times 20 is 240. So at the very least, she'll make $240 for the week for working the 20 hours. On the top end, if she does the whole 35, she'll get paid $420, and that's what she'll top out at. She won't make any more than that during the week because the most she will work is 35. And she can make any value in between these two numbers. So she can make $300, she can make $400, she can make $350, she could even make $363.24, depending on the number of hours she works. And if she has fractions of an hour in there. Okay? So that's how this one is different. This is a continuous function, not a discrete function like the other examples have been. All right, finally, for example 6, we have a bowling alley, and it can be rented for parties for a maximum of 5 hours, and you are charged for the full hour. So here, because we are charged for the full hour, it is going to be a discrete function. Okay, if we go into the next hour, we're getting charged for that full hour. The cost is $200 for the deposit plus $150 per hour. So our independent variable, our input, is going to be the number of hours. Our dependent variable, or our output, is going to be the total price we pay. So our function is going to be the cost per hour, 150 times the number of hours that we rented, plus the $200 deposit, which is just on top of whatever we pay. So for the domain, we could rent the place for 1, 2, 3, 4, or 5 hours. And for the range, we put in each of those values. So if we rent it for 1 hour, that's going to be $350. For 2 hours, that's going to be $500. Then we have $650, $800, and finally $950 is the most that we would pay if we rented it for the entire 5 hours. All right, this includes not only this section, but also this unit.